Hello and welcome to this video on the seemingly dangerous and fey toadstool. Toadstools are effectively just a mushroom. Some of them are distinct in coloration and appearance, but the key difference is simply one is poisonous, whereas one is edible. The most familiar, or at least most easily recognized kind, is distinctly red with white dots on them. In terms of myth and legend, they grow in circles, and these fungi were said to be part of fairies and other magical beings' life, environment, and so on. Beyond the mythical or legendary status of toadstools, they do have some real-world presence and significance. Real-world significance beyond the fact that people die from eating them. The most common form of fungi that are seen as toadstools is the fly agaric. This is also known as the fly amanita, or properly called the Amanita muscaria. Of note, remembering, a toadstool is just a mushroom, but poisonous. Oh yes, just in case this needs to be stated. Don't eat them. It's deadly, possibly, but if nothing else, you'll be very sick, and YouTube is stupid and might think that we're somehow encouraging you to do so, which... YouTube. Anyway, toadstools are going to be characterized by their structure, and by that we mean if you pick them up and look at them, which is a bad idea, you'll notice that there are certain things. Part of their cap, their gills, and there are spores. Of all these things, the thing you recognize most easily is the fruiting body. This is what you would consider to be the toadstool or mushroom, the weird umbrella-shaped structure. Now, not all of them will look like this. There is going to be variation in shape, size, and color. But for the most part, you can think of them as being essentially an umbrella in their shape if you look to a cross-section. That is, it is a wide, flattish top, and then you have a stem down the middle. Some will be slightly more convex, as in an upside-down umbrella, and some may even be more funnel-shaped. But let's just stick with what's most familiar to people. This would be the bright red mushroom-type toadstool with white dots on it. On the underside of this, you get to look at the gills. These are those lines spreading out from the inside of it. These are also where the spores will be produced. Now, the spores are important as they give rise to more mushrooms later on down the track. The spores get released from here and carried away by the wind if they're not dropped onto local soil. This allows them to be spread easily, and in some instances even animals may do so, and it's one of the ways of checking what mushroom or other fungi you have. The fly agaric itself is going to emerge from the soil, and it's going to look kind of like a white egg, which, when you first see it, you think, what the hell is this thing? And there will also be a number of small white, sometimes yellow, growths on it. They look kind of like a wart, and this will gradually go away, or at least shrink over time. As the mushroom grows, and the bigger stages, you get a layer of skin gets revealed, and that's part of why these disappear. As the mushroom gets bigger and more advanced in its development, the red coloration begins to show through. And this is why you wind up with white dots on it. Those dots are essentially those warts, but the coloration around it has been somewhat, let's say, washed away by that redness. The fly agaric mushroom is important, not just as we mentioned because of its weird mythological connections, but because it produces a number of rather useful, or at least useful when produced and used in a clinical setting, biologically active agents. Now, some of these are more useful than others in terms of what they do. For example, you have, say, muscimol. This is known to be a psychoactive. But then you have ibotenic acid, which is a neurotoxin, rather obviously. Both of these have very different uses. Generally speaking, if we're talking about just the dose that's going to work, you need about, let's say, 6 milligrams, so about 6,000ths of a gram of muscimol, and you need somewhere between 30 and 60 milligrams, or 30 to 60 thousandths of ibotenic acid. Now, you can find this amount, and it's one reason why there's an association with this in terms of its, let's say, deadliness, in just one mushroom. So literally, one mushroom is enough to possibly cause significant effects. Another noteworthy part to this is that, well, depending on when and where you harvest them, they can contain significantly more or less of these active agents. For example, collecting the mushrooms in spring and summer can yield up to 10 times more of these active ingredients. The other concern with them is rather more notable though. These are water-soluble compounds. Now, water-soluble compounds means they're very easy to dissolve in, rather obviously, water. But it also means that if they get into the bloodstream, they're not going to come out of suspension. The difference between this and other drugs, let's say, is that most drugs we use in a clinical setting are lipid-soluble. That is, basically, they're a fat-type product, or at least soluble in fat. That means they can get into the bloodstream more easily, but they don't stay in the bloodstream as easily. The other concern, though, is because water-soluble, if you boil them or add them to any sort of cooking water, you get the, to be blunt about it, the dangerous products extracted out and in your food as a whole. And so you may find that if you've made soup with these, well, now the entire soup is poisonous. Not exactly a good thing. That doesn't mean that there's no use, though, and this is where, for lack of a better way of phrasing this, we have a notable exception. The muscarine inside of the fly agaric is by itself not particularly useful. Again, it owes to things like inconsistent doses, unknown purity, and of course the clinical effect, which is, well, depending on what we're talking about, either hallucinogenic agent or something worse again. But that doesn't mean it can't be used, and we've known about it since about 1870, a little bit earlier. What's important with this is that the muscarinic, muscarine compound acts as an acetylcholine receptor antagonist. That is, it will bind to it and activate it, which means you can, to an extent, use it as an analog, which is useful. Some ways. We'll get to that in due course, but understand, it can be helpful. When we're talking about that, though, we need to note that before you look at the benefits, you need to note that there is danger to it. It is a poison. Let's be clear about this. It is dangerous. And of course, if you, dry the mushroom or the toadstool, or you do something similar, you actually concentrate that poison far more effectively. When you look at it in terms of what happens inside your body if you were to eat this, well, first of all, you actually get a fairly high dose, as we mentioned earlier. The onset of symptoms is going to be very quick. It can be as little as 20 minutes and possibly as late as 90 minutes. Although, as with all drugs, the higher the dose, the earlier the symptoms will begin to show because you've consumed more of it. The other concern, though, is when you try to excrete it, most of it gets excreted through the kidneys. And as a result, you find that, you need to clear it out. And if your kidneys aren't working very well, typically in older people or very young, you get a much worse clearance rate. In terms of its actual function, we mentioned early on, it's very similar in some ways to acetylcholine. And in fact, the two, compounds of interest, this being obetanic acid and your muscarine mimic or an analog, are very similar to each other, but they do work in two different ways. Your glutamic acid or GABA receptors each have different preferences. So as a rule, you'll find that the muscimol is more effective as a GABA agonist versus your obetanic acid, which is an agonist of MMDA glutamate receptors. There's also a few other receptors you can work on, but for the most part, that's its primary target. By targeting both of these, it's thought that the hallucinogenic and other psychoactive effects are facilitated. Beyond everything we've said about it, the fly agaric being poisonous, we did also mention that it can have uses, and this means toadstools aren't all bad. Well, they're mostly bad, as they are, but if properly processed and used, they are useful. In fact, the toxic compounds in the Amanita muscaria, or fly agaric, are very useful. It is the base for a series of medications that are out there, mostly looking at it being a muscarine mimic. Now, that's mostly because the previously mentioned ability to be an analog for acetylcholine, one of the major neurotransmitters. And if you're out to be an agonist for these receptors, you can, to a certain extent, replace muscarine or something similar, or in this case acetylcholine, in the human body to an extent. The major type of receptor within the muscarinic receptor family, let's call it, is nicotinic receptors, because these are distinct from the rest. To be very clear about it, the muscarinic receptors are part of the acetylcholine receptor family, But the rest of the acetylcholine receptors are not responsive to the muscarinic compounds, which is very important to note here. There are 5, let's say, subtypes of your acetylcholine receptors, or in this case, your nicotinic receptors, which are responsive, these being the M1, M2, M3, M4, and M5, the most imaginatively and creatively named of receptors. But these receptors are important and they do need to be differentiated. They're, to an extent, spread out across different tissues, and you get a mixture of each of these in the different parts of the body. For example, M2 and M3 typically are found in the peripheral autonomic nervous system and tissues. So think of things like, say, your muscles, your vascular system, and so on. M1 and M4 are more abundant in the brain and in the autonomic ganglia. Then we have other, distribution issues. For example, M1, M3, and M5 tend to be, more closely associated with the release of intracellular calcium. So, for example, something involved in the contraction of muscles. M2 and M4 tend to be involved more with the cyclic adenosine monophosphate, or CAMP, part of most biological processes and the various steps involved. What is interesting, though, is that just about all of the muscarine type agonists and the receptors they bond to aren't really selective, meaning that if you were to, for example, consume the mushroom and get a high dose of this, you would activate all of them, regardless of their location. There's no real selection process. But, on the other hand, it is possible that with a properly tailored and modified compound, you could, and that would be far more beneficial. In this case, the mushrooms won't make you healthy, and in fact, they will likely cause you harm, if not death. It might also explain some of the myths around toadstools. Hallucinogenic effects and other psychoactive products and effects would explain a lot of why people think there are fairies attached to them. It would also explain why people think they are dangerous, and not just because, people learn eventually, if you eat the bright red thing, you die, it's dangerous, but also you have a weird trip beforehand. They might be overlapping the two distinct phenomena. But at the same time, it is something we can use and have, in other respects, derived products from that are effective, and we know why they're effective, what they are. Just that they don't lead to fairies. Not yet, anyway. Give genetic engineers time, we'll get there. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. And please do post any comments, questions, or suggestions you have below.